So today we're going to learn how to predict the products of a double replacement reaction when only given the reactants. We're going to work through it step by step. And if you follow the steps and understood the old material, then this should not be difficult for you. Okay, but it is very important that if you were struggling with ionic compounds, you pay extra attention, because we are going to review how ionic compounds are written, but it's going to be quickly. Okay, so there's essentially 5 steps that we're going to follow when we write the products of a double replacement reaction. First of all, double replacement reactions are all compounds, meaning your reactants are going to be ionic compounds and your products are going to be ionic compounds. That means you're going to have a metal and a non-metal for every single one of the things that is separated by a plus sign. When we write ionic compounds, we use the charges of the ions in the compound to figure out the formula for the resulting compound. Okay, and we'll practice those so that you can see what I mean. So essentially the steps are going to look something like this, and then we're going to talk through the steps. But what I will tell you is that what I have written up top there is wrong, and it has to do with the ratio that the elements are combined in. So we'll go through that. So number 1, we're going to just do a basic prediction of what is formed by rearranging our element symbols, okay, and pairing them up with new elements. Then we're going to check the charges of our ions, write new formulas based on 0 net charge, balance the final equation, and then use our solubility rules to determine the states of matter of the product. So there's a lot of steps involved, but once you get good at them, they're really not difficult. Okay, so what you're going to see is something like this: NaCl plus BaO. And that's all you're going to get. And I'm going to ask you to determine what is formed. So essentially, we're trying to figure out what products are going to form here. Now, I know that this is going to be a double replacement reaction because we are starting with 2 compounds. Okay, so the only types of reactions that have 2 compounds as their reactants are going to be double replacement. So this is going to tell me, okay, I need to go through these steps for a double replacement reaction to figure out the products. Step 1 says predict what is formed in the reaction. Rearrange the element symbols without subscripts. Now, there's no subscripts here anyhow. Subscripts, remember, are the little numbers that would be written after the letters. So this one is going to be a little more straightforward, but we will do some that have subscripts. So the first thing I want you to do, and this is really the best way to do this, at least in the beginning until you're comfortable, is take each of your chemical formulas, look at the element symbols only. Okay, again, there's no subscripts here, so it doesn't matter. And you're going to write them to the side. So I'm going to put Na and Cl next to each other. Okay, I left a little space because I know I'm going to do something in between there. So that's my NaCl. Notice all I did was write the element symbols. Ba and O, I'm going to do the same thing, but I'm going to list it below there. Okay, again, I'm going to split it up. Now, the reason we did this is going to help us figure out what our new combinations are going to be over here on the right-hand side. What element is going to pair with what element? We're going to draw an arrow from the left element to the right element, and we're going to crisscross them. Okay, so Na is going to join with O, and I'm going to write that in this space. And Ba is going to join with Cl, and I'm going to write it in that space. The reason I wrote Na before O is because Na is the metal, and the reason I wrote Ba before Cl is because Ba is the metal, and the metal always comes first. But again, as long as you follow this pattern here where you crisscross them, you won't do that part incorrectly. Okay, now I'm going to take a moment to talk about ionic compounds before we talk about the correct formulas for the products. When Na and Cl were joined together on the reactant side, the reason the formula is NaCl and not Na2Cl or NaCl2 or any other formula has to do with the charges of the ions. Okay, because this is an ionic compound, we know that these were ions. The sodium ion always has the same charge, and that charge is +1. Okay, you should have that periodic table labeled somewhere. The Cl ion is always the same charge, and that charge is -1. So when we look at this, remember that in any ionic compound, your charges must, quote unquote, balance out, cancel each other, add up to 0, however you like to think of it. Your total charge has to be 0, and +1 and -1 add up to 0. So therefore, we know that the ratio of these ions is correct. It only takes 1 sodium and 1 chlorine ion for your charges to add up to 0. So that's why the formula is NaCl, no other reason. When we look at BaO, again, the reason the formula is BaO has to do with the charges. Ba's ion is +2, O's ion is -2. So again, +2 and -2 add up to 0. So that's why it only took 1 of each of those ions for that formula. So BaO is the correct formula. But let's take a look at what happens when they're rearranged. Na is now combined with O, but the charge of the ion doesn't change, okay? The Na ion is always +1. So I'm just going to write this over to the side here in my scratch area. I'm going to write the charges of my ions. The O ion is always -2. So if Na is +1 and O is -2, do those charges add up to 0? Do those charges add up to 0? Dan, what do you think? You need to pay attention to this. Do +1 and -2 add up to 0? +1 and -2, if you add those together, you get 0? No, you don't, okay? Guys, anyone that's zoning off right now, unless you are a straight A student in here, you need to pay attention because you will fail this quarter miserably. Like, we're talking 20% miserably, okay? +1 and -2 are the charges. They do not add up to 0. The way that a chemical formula is written for an ionic compound is based on the charges. How many NAs does it take to make the total charge of 0? Well, we would need 2 Na ions with a +2 charge to balance out our 1 O2 with a -1 charge. And that is how we get the chemical formula. We need to write the subscript 2 after Na to balance out that -2 charge. Okay, when you are determining this portion, these are subscripts. When you count the ions, it becomes a subscript in the chemical formula. So the correct formula is not NaO, it is Na2O, because the charges must balance out. Now let's look at barium and chlorine. Again, barium always has a +2 charge, so I'm going to actually write that in both places. Chlorine always has a -1 charge when it's part of an ionic compound. So now, do +2 and -1 equal 0, Dan? No, they don't. So now we have to figure out the correct ratio for those to balance out. So if Ba is +2 and Cl is -1, we actually need 2 chlorines to balance out that +2. So that's why we get a subscript 2 there. Okay, now I'm just writing these charges up here because it gives us space to work. And you're welcome to do that if it helps you figure out your formulas. You can write them to the side like I did here, okay, however you want to do it. But you must remember that the formulas in a double replacement reaction come from the charges of the ions. So what has that done for us? That has gotten us to step 3. We predicted what was formed by crisscrossing our symbols. We checked the charges of our ions, which we did there. And now we've written the correct formulas based on those charges adding up to 0. The next step, we have to balance our equation. So once you know your formulas are correct, based on writing subscripts to balance out your charges, this is where the coefficients come in. The coefficients are what we use in front of our formulas to balance out the total number of atoms that we have, okay? Because now they may not be even. Okay, so this is where we set up our T-chart if you need one still, and you balance it. So I'm going to set it up here to the side. My reactants, my products, I have Na, Cl, Ba, and O. On the left, we have 1 Na. On the right, we have 2. So now we need to fix that. We put a 2 in front of the Na. That gives us 2 chlorines on the left, and we have 2 chlorines on the right. We have 1 Ba on the left. We have 1 Ba on the right. We have 1 O on the left, and we have 1 O on the right. Okay, so it only took 1 coefficient. Again, we can put 1s in those spots. You don't have to put them there, but if we are doing something in plastic, I would like the 1s there, just because it fills those spaces. Okay, so we're almost done. There's one last step in a double replacement reaction that we don't have to do any others in any other, and it relates to the solubility rules. We need to know the states of matter of the products in a double replacement reaction. So we're going to go to our solubility rules and we're going to look them up. Now, remember that it's the second element. Oop, we're going to finish tomorrow. And then don't forget there is a quiz on Class Kick Part 3 with reaction types and solubility rules.